Assalamu alaikum guys, welcome back. Okay, so now in this video we are going to talk about period 3's next lecture. Okay, this is the second lecture of period 3. I guess we started out, we did the intro of period 3 in the previous lecture, and now we're going to start out with the trends of ionic radii. Okay, how does the ionic radius changes across the period. We talked about the atomic radius in the previous lecture. We talked about the ionization energy, and we talked about the charge density and electronegativity in the previous lecture. In this lecture we are going to talk about the ionic radii, meaning the radius of the ions which these elements form. These are the period 3 elements. Okay, now you guys must know that sodium, magnesium and aluminum, these are they form positive ions, cations, by losing electrons, whereas phosphorus, sulfur and chlorine, they accept electrons, okay, forming anions. So these are anions and these are cation forming atoms. Silicon on the other hand can form both cations and anions because it's metalloid. It has both metallic and non-metallic properties. Okay, so it can form silicon 4 positive or 4 negative. Phosphorus accepts 3 electrons because it's in group 5, and so if it accepts 3 electrons, it will stabilize its outermost shell and hence will form the phosphide ion. Sulfur will accept 2 electrons and stabilize its outermost shell with 8 electrons, and chlorine will accept 1 electron forming chloride ion and stabilize its outermost shell. The same applies over here. These ions, since they have extra, they have 1 electron in the outermost shell, so they can lose it, or 2 or 3. All of these electrons can be lost to stabilize their configuration. So now this is the graphical representation. Okay, in this middle line that I have drawn over here, this is actually the atomic radius trend, a general trend. Okay, and this is not a very accurate diagram. This is just showing you a general trend. That you remember I told you in the previous lecture that sodium has the largest radius, followed by magnesium, then aluminum, then silicon, then phosphorus, then sulfur, then chlorine. Okay, and so on, and argon is an exception, so we are not including argon in this discussion. So generally the atomic radius decreases, so it decreases like this. Okay, now if this is the sodium atom over here, the sodium ion must be smaller in radius, or will it be larger than in radius than the sodium atom? It's gonna be smaller. Why? Because sodium atom, for instance, this was our sodium atom. This is the first shell, this is the second shell, this is the third shell. Third shell has 1 electron. Now this atom has a particular radius. Okay, then after losing the outermost shell, meaning outermost electron is lost, so that means it has lost an entire shell. Its radius is of course gonna be smaller, right? For this sodium positive ion, the radius is gonna be smaller than the atom, so it's gonna be less. Okay, so this is the sodium ion. Then followed by magnesium. Magnesium is gonna be even less than the sodium ion because it has lost 2 electrons, and the nucleus is more has a greater charge than the nucleus of sodium. So this greater charged nucleus of magnesium will attract the electron density more tightly, more effectively, reducing the radius even further, and so aluminum and so silicon. Okay, so there is a decreasing trend over here till silicon. But silicon on the other hand, if it loses electrons, it's gonna have the smallest radius in the positive ions. But what if silicon accepts the electrons? Meaning, this is the outermost shell of silicon. It had 4 electrons originally, and now it accepts 4 more electrons. If it accepts 4 more electrons, this means that now the number of electrons become more than the number of protons present in the nucleus. So this would eventually decrease the effective nuclear attraction on the outermost on the electrons which are present. What is effective nuclear attraction? It is basically the attraction which is exerted by the nucleus on the number of electrons in the atom. If the atom and electrons and protons are equal, they experience a certain amount of attraction by the nucleus. But if the electrons become more than the protons in the nucleus, then this effective nuclear attraction, it distributes and it becomes even lesser. Okay, so over here the nuclear attraction is going to become weaker on all the electrons, and so the electron density will expand, and as it expands, the Si4 negative ion will have a larger radius than the Si atom. The silicon ion, the silicon 4 negative ion, the anion of silicon, will have a larger radius. Then phosphorus ion, meaning the phosphide ion, will also accept 3 electrons. Now will also accept electrons, but it will accept 3 electrons. Since it has accepted 3 electrons, it has a greater nuclear attraction, right, effective nuclear attraction, than the phosphorus atom, but it's going to be less than the silicon. Okay, it's going to reduce, but it's going to stay above phosphorus. Now on your exams, the examiner usually ignores the silicon. Okay, usually ignores the silicon and ask you which of these elements will have the largest radius. Okay, which of the anions will have the largest radius? So it's phosphide ion. Okay, then followed by sulfide and then chloride, and the reason remains the same, because as we go across the period, it's the nuclear charge is increasing, so the electrons, the pull on the electrons by the nucleus will keep on increasing, due to which the radius will decrease as we go and reach chloride. Okay, argon has been omitted because argon is a noble gas, so we are not gonna talk about it, it's an exception. And this sums up the ionic radii. So just a quick recap: sodium ion, which is going to be less than the sodium atom. Then comes magnesium ion, which is going to be even smaller than sodium, and then aluminum is going to be smaller. Let's forget about silicon, okay, because silicon has dual characteristics, so let's not put silicon over here. After aluminum will come phosphorus, so it's a phosphide ion. Then comes the sulfide ion, which will have a smaller radius than phosphorus, and then comes the chloride ion. Now if we omit silicon and if we omit argon, so the ion with the largest radius is phosphide ion. Okay, this has been an MCQ in which the silicon and argon were omitted and you were asked to identify the ion with the largest radius. So it's the phosphide ion with the largest radius. Okay, and the ion with the smallest radius is of course going to be Al3 positive. And this sums up the discussion of ionic radii trend. In the next lecture we are going to look at the next trend, which is most probably either going to be one of the trends. Okay, thank you.